So how do we actually perform operations with polynomials? Well, here we have two polynomials, two cubics. To add them together, we're going to do x cubed plus 2x cubed is 3x cubed. Minus 2x squared plus 1x squared is minus x squared. 3x plus no x's is plus 3x, and minus 5 plus minus 11 is minus 16. We're just collecting like terms. Subtracting x cubed minus 2x cubed is minus x cubed. Minus 2x squared minus x squared is minus 3x squared. 3x minus 0x is plus 3x. And minus 5 minus negative 11 is minus 5 plus 11, so that's going to be plus 6. Two lots of px is two lots of this, so it's going to be 2x cubed minus 4x squared plus 6x minus 10, doubling each of the coefficients. Minus 3 lots of qx will be minus 6x cubed minus 3x squared plus 33. And now we move on to the multiplication. P of x times q of x. Now I've lost the polynomials off the top, so let's just remind ourselves this is going to be x cubed minus 2x squared plus 3x minus 5 times by 2x cubed plus x squared minus 11. Now there are multiple ways of doing this. We could expand this x cubed times x, 2x cubed times x squared, x cubed times minus 11, and then minus 2x squared times each of those things and go through one at a time. Now the problem with that is it's quite easy to lose track of what's going on. So I'm going to show you a method, the grid method. You may have seen the grid method for multiplying pairs of brackets, pairs of sort of linear brackets, or indeed for multiplying numbers when you learn how to multiply numbers. If you haven't, I'm going to show you it now. It's fairly easy, and I like it because when we come to polynomial division, it's very easy to undo and do the reverse process, a lot easier than some of the other methods for polynomial division. So for the grid method, we write out a big grid, and across the top we're going to write one of our polynomials, x cubed, but each of these bits is a separate bit. So x cubed minus 2x squared, 3x, and minus 5. We're treating them separately. And then down the side we're going to do the other one, 2x cubed, x squared, and minus 11. And then we multiply each of these pairs together. Now we're doing exactly the same thing as if we had done this bit at a time. We're multiplying everything in the first bracket by everything in the second bracket. This grid just gives us a nice way to make sure that we've done everything. So 2x cubed times x cubed is 2x to the 6. It's going to be minus 4x to the 5, 6x to the 4, and minus 10x cubed. And then x to the 5, minus 2x to the 4, 3x cubed, minus 5x squared, and final row is minus 11x cubed, 22x squared, minus 33x, and 55. And so our answer is just adding all these bits together. It's going to be 2x to the 6, x to the 5 minus 4x to the 5, so plus x to the 5. X to the minus 2x to the 4 and 6x to the 4 is going to be plus 4x to the 4. The x cubed is going to be minus 21, and then plus that is going to be minus 18x cubed. 22x squared minus 5x squared is 17x squared minus 33x is plus 55. Now what you might have noticed is here I didn't have an x. If I put that x in, we notice something else. Here I would have ended up with 0x to the 4, 0x cubed, 0x squared and 0x. And the only reason I'm highlighting this now is because actually this is quite a helpful thing when we come back to division, because you will notice that across the diagonals going along here, we now have all the same powers. And when we come to division, that's a very useful thing to know. Now, the reason we didn't get that in this case was because there were 0x's. So we can write that in to make sure we get those diagonals. We don't need it for multiplication, but that pattern's going to be very helpful, as I said, when we come to division.